Here we are with our second identity, similar to the one we just did. Again, I'm going to start on the more complicated side. I'm going to start on the right here. And I'm going toward tan 2a. Now, we do not have a formula, double angle formula for tangent. We haven't proved it. In fact, this is the tangent double angle formula if you looked it up. But we're trying to prove why it's true. Well, I know that tangent is sine over cosine. So what I'm going to try to do is I'm going to try to make this side look like the sine of 2a over the cosine of 2a. And I'm going to have my eye out for those two formulas as I kind of work on this side. So I'm going to start on the right here. And I'm going to, again, rewrite top and bottom in terms of sines and cosines. So this is 2 sine theta over cosine theta. That's the numerator. Tangent theta is sine over cosine. This is 1 minus. This kind of looks like the Pythagorean identity, but if you check it, it's not quite the Pythagorean identity. So instead, I'm just going to write it as 1 over sine theta squared over cosine squared of theta squared. Now, at this point, I say to myself, well, you know, it's kind of a pain because I have this subtraction down here, and I don't really want to have like a fraction in a fraction. So I'm going to get a common denominator in...
Aubrey Schaefer, please come to the office. Aubrey Schaefer, please come to the office.
I'm going to get a common denominator in this fraction. So I'll do that by doing the following. I'm going to rewrite this 1. I'm going to kind of multiply, make this 1 over 1, and multiply it by cosine squared on the top and the bottom. Cosine squared here, cosine squared there. So I get cosine squared minus sine squared over that common denominator is cosine squared. So check that step on your own. Go through those steps carefully, make sure you understand it. But basically I'm taking that 1 and multiplying the top and the bottom by this denominator so that I have a common denominator, and then I pull the fractions into a single fraction. The reason I do that is I'm now ready to flip and multiply. This fraction flips and multiplies by that fraction. So I have 2 sine theta over cosine theta times, when I flip, I get cosine squared theta over cosine squared theta minus sine squared theta. One of my cosines cancels out. I have 2 sine theta cosine theta. Oh, that's sine 2 theta. Over cosine squared minus sine squared, that is the cosine of 2 theta. And the sine of an angle divided by cosine of an angle is tangent of twice that angle. So that is done.